Okay, for some of my first recorded videos, I wanted to go over some homework stuff, probably because it's easier to do live. Here's Chapter 2 stuff. Chapter 2 is very involved. This is 1 through 10. Hint, hint, hint. These are also a bunch of equations that are pretty handy to have. Might snapshot that, just saying. And I'm going to work a problem similar to what's assigned. And looks like I've got the assigned ones marked here. So I'm going to work problem 26, which is very similar to problem 25, which is assigned on the homework. 26 is in metric units, and 25 is in standard units. So that's pretty much the difference. Other than that, it's the same problem. This is a great textbook as far as the examples go. It's one of the reasons why I like it a bunch. And so definitely look at the examples in the textbook. I want to read the problem, explain the problem, and then do the problem a little bit. I think that'll be helpful. So in 26 it says, in a system, and that means hydraulic system, that will have a flow rate of 75 liters per minute, that's what LPM is to have it has been determined that the flow velocity should not exceed 6 meters per second. So that's a velocity. So basically they're saying there's a hydraulic system that has a certain amount of fluid going through it, 75 liters per minute, and they do not want the flow rate to go beyond 6 meters per second. What is the minimum conduit? And if you look around at some of the equations, you'll see that flow rate is indirectly proportional to the size of the pipe, meaning bigger pipe, flow rate's not, the velocity is. Flow rate's pretty constant. If you have a big pipe, you get the same amount of flow moving slower. If you put on a little pipe, you get the same amount of flow moving very fast. In this problem, they're saying, hey, there's a limit to how fast it can flow. It's 6 meters per second. There's a lot of reasons for that. It doesn't have to say, but you get fluid moving too fast in a pipe, it's noisy, it creates heat. There's some stuff we don't even get into with fluid dynamics that have to do with the friction inside the pipe and what it does to the hydraulic fluid. But this is saying, hey, there's a pump that flows X amount, and the velocity should not exceed X amount. What size pipe should I use? What's the smallest pipe I can use? I can use bigger pipe all day. The reason why you just wouldn't want to stick bigger pipe on everything is because it might be expensive. It might take up a lot of space. Who knows? So again, there's a shot of the textbook. I was reading problem 26, and then there's also some other shots of the textbook. So for those of you that don't have a textbook, that might be helpful. Alright, so to work this problem, flow rate, so it's number 26, chapter 2, flow rate is usually in units of volume over time, and it usually has Q as its variable. So I don't know why I wrote valve when I mean volume over time. So Q is the variable, it's volume over time. And let's see how liters, so what we have is a Q equal to 75, and I like to write liters because it makes me sound smart. Liters per minute, that's what our Q is, given from problem 26. And then they want the velocity, which is V, right, velocity, 6 meters per second, not to exceed. And then they basically want to know what is the area of, they call it the conduit, it's really the pipe. What's the area of the pipe? And that's the question. So it's really nice if you just go back and look at these. A lot of times I don't teach to the equations, but I think it's better to do this particular quarter. And I also think, I'm just going to say this before I get going, we're going to set this problem up and stop, and then I'll solve it in another clip, because this is already taking quite a long time. So somewhere in here is Q. It equals velocity times area. in any consistent units, this book says. So now we have to figure out what consistent units are for our liters and our meters, and I'm going to stop right there.